Well, welcome everybody to Big Picture Weather Planning for Summertime Flying. So we're going to be talking about the big picture tonight. And I'll say this a little bit later, but I make most of my decisions by looking at the big picture. The details are important, as we'll get into. Ultimately, it's the big picture that will make or break the decision that I make for flying. All right, so my name is Scott Dennstaedt, and I'm a CFI and former National Weather Service meteorologist. So I've been doing instruction for a little over 20 years or so. And I'm also EAA's subject matter expert on weather. So you may have seen a few webinars I've done with the EAA folks. And I'm also the founder of the newest weather application out there called EasyWX Brief, or Easy Weather Brief. And that's easywxbrief.com. All right, so the first point, and that is, you see this accident that occurred here. And I've shown this on other webinars I've done. It looks pretty nasty. Evidently, a pickup truck has found their way on the other side of this guardrail, and you look at it and you say it's a pretty bad accident overall. And certainly all the details that you see here are really important, but when you kind of and look at the actual situation, well, the details were important, but that big picture is certainly the king. Whoever that was in that pickup truck survived a really potentially deadly accident. So the big picture, don't miss the big picture, because that will tell you more than anything else. And we'll try to go through that for some hints and some guidance on summertime flying. All right, so don't need you to answer this literally, but think about this. What is the most significant weather threat for summertime flying? And let me give you a hint. It's not thunderstorms. Yes, thunderstorms are dangerous, but it certainly doesn't take a full-blown thunderstorm to ruin your day. So I like to tell folks the key is to minimize your exposure, not to thunderstorms, but to deep, moist convection. So you've probably seen in the Aviation Weather Advisory Circular 00-06B, or in maybe other texts, this picture of the thunderstorm life cycle. First, they start out with the towering cumulus stage, goes into the mature stage, and finally the dissipating stage. Nothing wrong with this picture, but the problem is they don't really provide enough information about what's going on in this first stage and tying it all together so you can make really good decisions before you depart. And so I'm going to kind of focus, at least initially, on that element, and then we'll get into looking at some charts and what charts are necessary for that big picture decision making. So a few years ago, I was asked a question about what is a thunderstorm? How to define a thunderstorm for me. And I finally found one I thought was the best description of a thunderstorm. And that's from the National Severe Storms Lab. It's a rain shower during which you hear thunder. Since thunder comes from lightning, then all thunderstorms have lightning. But the key element here is a rain shower that has lightning. Seems like a small detail, maybe kind of unimportant to some folks, but I want to focus a little bit on that concept of a rain shower. All thunderstorms essentially start out as a rain shower. For a lot of folks, the word showery, precipitation doesn't really excite folks too much. We know that not all rain showers grow up to be thunderstorms as well. That's another aspect of this. So the rain shower itself is really just the beginning of the convective process. So when you hear the term showery precip, you should think deep moist convection, and ultimately that's the beginning of the convective process in place. So rain showers should be a key element as you're going through your briefing, whether you're hearing that from briefer themselves or you're reading it through a TAF. We'll go through some of those things, but ultimately it's important to understand that a rain shower is critical in your overall briefing process. So why should you care about this? Well, here you are flying, and it may be a little difficult to see this image, but essentially you have a shelf cloud here. Would I just make a right turn and say, I'm going to head into that supercell thunderstorm? Of course I wouldn't. Why? Because it looks threatening. I'm not going to do that. It looks threatening. Probably if I'm pulling up my Sirius XM on my iPad and I'm looking at that particular cell, I'm just not going to go there. It's just too threatening. Now, let's look at this picture. And I've shown it using I've done this in other webinars, but if you look at this picture, does this look as threatening? It really doesn't. Lots of blue sky around. You got some kind of dark clouds at the bottom. Doesn't seem very threatening at all, but let's take a look at something here. And so again, you look at this picture and you think it's not really all that threatening looking. And this is if you were from on the ground looking out, but imagine you're flying into this area and there's an airport below right there, and you think, oh, I see the airport. The bases are pretty high. It looks very inviting. But as you can see, that's not a good situation. I'll run it by a couple times here so you can see it. Maybe a little difficult with the internet to see that, but ultimately what you're looking at here is a wet microburst. Something that came out of a shower, basically, if you call that. It's a shower. There was no lightning in this at all. So you technically can't call it a thunderstorm. So it didn't look very threatening. However, I would not have wanted to be under that when that precipitation core let go. If I'm in a small airplane, I don't know if I could overcome the momentum of that if I'm in my pattern trying to land on short final. So this rain shower may not look all that threatening initially, but it can be just as dangerous. I always tell folks, beware of the benign. We haven't had any major airline accidents because they flew into a supercell thunderstorm. The Dallas-Fort Worth L1011 accident was one example. That was not a supercell thunderstorm. That was a thunderstorm that had very high bases to it, did not look very threatening, unfortunately was met with something like you just saw here. So when you're briefing convection, the word uncertainty should kind of bubble up to the top, because it's very, very difficult to forecast convection with any kind of certainty more than about 12 hours in advance. I always have to laugh when I look at a terminal forecast, let's say for sometime tomorrow, let's say mid-morning or early afternoon for the next day, and the forecaster puts TSRA in for thunderstorms and rain in the terminal area. I have to chuckle a little bit because they're really, that's a stretch to be able to do something like that, to forecast thunderstorms for the terminal area more than about 12 hours out. But you can usually get a pretty good idea where the problem areas are going to be, how this is all going to evolve. The real issue comes down to timing. We have a pretty good understanding of whether this system will evolve and produce convection, produce thunderstorms. That's not too awful difficult, but to be able to time it right can be quite difficult. Now, if you're out in the western U.S., west of the Continental Divide, most of the convection is of the afternoon variety, called diurnal thunderstorms, diurnal convection. And usually you can set your watch by those, and even in the southeastern U.S. sometimes, but that may not be true elsewhere. It may be very difficult to get a really good idea of what's happening, especially when they're frontal based. In some cases, they may develop earlier than expected, and so it's really hard to really nail down the timing of convection with any degree of certainty. So when you're looking at the big picture, you're really not trying to look at exact timing per se. What you're trying to do as best as you can is trying to understand what's driving the weather and whether or not convection is possible, and kind of trying to isolate somewhat of that time frame where convection is most likely to happen. And that will be a time frame rather than specific times. Like if I say I'm going to depart at, let's say 2 p.m., you may have to have a range of time that you're comfortable with from that standpoint. And we'll look at some of the products that you can use to help refine that timing as best as possible. So one of the questions I get all the time, if I go to one of these shows like AirVenture, do a presentation, somebody always comes up and says, Scott, you must have the perfect approach to doing pre-flight weather planning. You're a CFI, you're a pilot, you're a meteorologist. You got to have the best possible approach to doing this. And the answer is I really don't. I don't have this magical approach that you look at these 35 things in this order and you're done. Ultimately, it's just through a lot of analysis, understanding what's going on. But my general approach is this funnel approach. I start with the big picture first, and I rely on the big picture more than anything else. And that's what we're going to focus on in this presentation. And then as I get closer to my departure time, I start to fill in those details. Those details are important, of course, but most of my decisions are not based in some of those details. Most of my decisions are based in that big picture of what's driving the weather. And often I can usually pick out a bad situation pretty early in the process, a day or two out, and know that this is going to be a challenging situation. And I wake up on the morning that I was planning to fly, and usually I'm pretty much right on target with that. So here's the magic that I use, if you will. And I like to say focus on precipitation areas. Focus on precipitation areas. We know precipitation. We know we have IFR conditions, poor visibility, low ceilings, usually possibility of convection, possibility of icing if you're flying high enough or if it's cold enough out, possibility of turbulence, convective turbulence, non-convective turbulence, all tend to hang in around areas of precipitation. So those are the problem areas we need to focus on. It doesn't say that you couldn't find yourself in some really bad weather outside of areas of precipitation. That can certainly happen. But those areas of precipitation are hotspots for concern. And we need to drill down pretty deeply to understand the threats that we'll have to, or the risks that we'll take in those areas of precip. So I generally start and I look at different products, and I'll try to go through most of these tonight. This is really a subset of weather guidance that I use. There's more details. I provide a lot of these products on my Easy Weather Brief application, but you can get these through government sites, through some apps that are out there. And certainly you may have your own favorites that you use as well. Usually 3 to 7 days out, or maybe I'm making a round-robin flight going from one airport back to the next, and I'm trying to kind of see if I can get back home after a few days. The 3 to 7 day range is when I kind of start the process. And I'm trying to identify where those precip areas are possible. And I'm going to use, and I'll show you this 12-hour probability precipitation, of course the prog charts. And one of them is the constant pressure charts, which I think most pilots just don't have a clue how to interpret. But if I have a buddy of mine who comes to me and says, Scott, I'm going to make a trip on next Tuesday, what do you think? Usually I head to the constant pressure charts because they really tell you where the energy in the atmosphere is. And how to interpret those, I'm not going to be able to go into tonight per se, but ultimately when it comes down to it, there's a lot of information packed in those constant pressure charts that can give you the answer you're looking for. And at 2 to 3 days, a few more different pieces of guidance, weather guidance, comes into play. We can look at the 6-hour quantitative precipitation forecasts. We can also look at the Storm Prediction Center's thunderstorm or convective outlooks. There's also something that I like. It's called the Short Range Ensemble Forecast Thunderstorm Outlooks, which again allows me to further refine the timing that you see in these other outlooks from the Storm Prediction Center. Usually the night before or the day before, and for me it's usually the night before I'm going to fly the next day, this is where I'm kind of really spending, let's say, 80% of my time looking at the weather. This is where I'm kind of really focused on the big pictures. Not a lot of detail, so I have to focus on the big picture here. And so I'm trying to determine here what precipitation might likely be convective. And so I pull in all the same information I had for the previous time, the 6-hour QPF, the prog charts, the outlooks, and then I bring in other products such as the Localized Aviation MOS program, that's that LAMP MOS, which gives a great forecast for convection, and we'll see that. Various forecast radar, there's lots of them out there. And also something I really like, it's from the High Resolution Ensemble forecast, echo tops greater than 30,000 feet, and I'll show that to you as well. And so my focus here is just to stick and look at the big picture and try to understand what is driving this particular weather. And I'm also, again, looking at constant pressure charts as well to kind of roll all that together and see what's happening with the trends of the weather over the last several days. And I'm also looking for details that and I say details. I'm looking for pieces of information where I can at least at some point provide some kind of certainty in my own mind of whether this flight is possible or not. Because I may be out at 3 days in advance making changes to my departure time. It may be that the day I plan to depart, the weather's just not going to be acceptable. I may be going a day early or later. That's also what you're going to be looking at too. And of course, on the day of the flight, I'm not really spending a whole lot of time looking at the weather. Instead, I'm kind of filling in the gaps of what I couldn't see the previous night. I'm looking at, for instance, some enhanced resolution thunderstorm outlooks from the Storm Prediction Center, the Aviation Weather Center convective outlooks. Of course, you're going to be looking at NEXRAD, TAFs, and METARs, rechecking the LAMP MOS product, as well as forecast radar again, and the Short Range Ensemble forecast and the EchoTops product. So all those I'm going through and trying to understand and fill in the gaps. And hopefully I'm just basically touching, essentially looking at some small details to fill in what is the freezing level expected to be, for instance, and just how strong the winds are going to be when I reach my destination. Am I going to have to worry about trying to get to a location while a frontal system is moving in with some convection along that front? Hopefully I won't have to do too much work here, because it should match a lot of what I saw the night before. And of course, if it doesn't, then I have to dig further. But the goal for this is really just to look at all the fine details. I didn't include pilot reports. I couldn't fit them in here, but pilot reports would also be something you want to look at as well. So this is a kind of a good overview of kind of the process that's in my head, is how I would walk through this. And I'm going to show each one of these various different charts and kind of just briefly explain each as we have some time. So again, that 3 to 7 days out, I'm really just looking at the gross level. Where is there going to be precipitation? So this 12-hour probability of precipitation really fits the bill. And so this is showing it out of the Easy Weather Brief application, but ultimately I think there are other apps out there, or you can go to the Weather Prediction Center, and it's located on that website. And so you can see here there's a high probability, high certainty of precipitation along this. And you can almost see that this is probably frontal based, because you have this kind of a line, linear fashion here that's occurring. So if you were trying to make a trip from my hometown here in Charlotte up to maybe Chicago, that's probably going to be a challenging flight sometime in that 12-hour period. So I may be thinking of changing my day that I'm going to be flying in this particular case. But if I'm flying, let's say, from Duluth, Minnesota, let's say to Cheyenne, Wyoming, that actually might not be too bad, because in this case I've got a lot of numbers that are really high here, so it's a high possibility, so a lot of certainty. The forecaster has a lot of certainty that there's going to be precipitation in here. You don't know if it's going to be convective, snow or rain. It doesn't tell you that, but from an overall big picture standpoint, it's pretty easy to see that this is going to be a challenging area. And maybe not so challenging areas here. You see brown with a lot of goose eggs all around, means that the forecaster has a lot of certainty there's not going to be much in the way of precipitation in those areas. And of course, you always want to tie that together with the long range or prog charts that give you good information, but it's certainly only at a specific time here, in this case at 12Z. So it's whereas the other one was a 12-hour range of time, this is basically showing you instantaneously what's being expected here. And the prog charts really give you the kind of more of the timing aspect of things. And so this was around the same time that other 3 to 7 day range that we were looking at earlier for the probability of precipitation. We can see that I said it looked like kind of a linear fashion here. Here's a frontal system that's associated with that. And also it tries to attempt to show you where the convection would be. So anywhere you see a slashed area here, that means you have a chance of thunderstorms. Again, I try to say just a chance of deep moist convection in that area, because you could still have a lot of showery precip and not necessarily thunderstorms along that area. But again, this is kind of showing you a broad brush of what's happening overall in this area. So the darker colors have a higher probability, not that it's light rain or heavy rain, it's a higher probability that you'll see precipitation, in this case convection. And the lighter green areas would be areas where you would have less of a chance of the precipitation type. So here in Indiana, most of Indiana is under the green, light green, and it's not hatched in all that area, so they're not expecting it to be convective in those regions. But everywhere that you see a hatched area, you're definitely looking at the possibility of a convective precip area. And I said earlier that I think it's real important for pilots to understand how to read and utilize one of these constant pressure charts. And this happens to be at 500 millibars, probably my favorite level to look at. I call this the belly button or the waistline of the atmosphere, because half of the mass of the atmosphere is above 500 millibars and half of the mass is below, roughly at 18,000 feet. And what you're looking for are the patterns that exist here. And you can see that we have a big ridge of high heights in this area. Really can't say high pressure because everywhere on this chart it's 500 millibars, so it's constant. But there's a ridge, which usually means you have warm air being pushed up, and so we saw that in this region the weather was pretty nice overall in terms of it was probably very hot when there's been some record breaking heat throughout the western U.S. But essentially we're talking about substance or sinking air in those ridges. And then here's a trough here in the east, so we have a trough that's moving down from the Great Lakes. And there's a lot of things, I'm not going to be able to go into all the details, but you can look at the tilt of the trough as a way of understanding what's going on, as well as kind of how that trough is going to evolve. And ultimately what you don't want to be is on the downwind side of this trough. If you draw this axis that basically cuts the trough into two equal parts, the downwind side of that. So we know that that weather system actually has a pretty good upper level support with it. So in the end, when you're looking at this many days out, this gives me a good feeling that, hey, if I'm going to be flying anywhere kind of downwind of this trough axis, then I'm going to have some difficulty there. But maybe upwind on the other side of that, not so much so. In fact, usually the best situation is to kind of be flying. Let me go ahead and bring my little pen out here. Kind of be flying, well, the colors didn't work out too well here, but here's the ridge axis that you can see here, and here's kind of the trough axis right here. And so basically the points in between the two are usually pretty fair weather overall. The next product I kind of look at as I'm getting closer, 1 to 3 days out, is this Quantitative Precipitation Forecast, QPF. QPF, again, doesn't tell you about whether or not it's going to be convective or non-convective. It's going to be snow, rain, ice pellets, or hail. It doesn't tell you what kind of precipitation. It just gives you the quantity of precipitation. So ultimately, when I look at something like this, if I were to make a flight, let's say from Atlanta up to, let's say, Des Moines, Iowa, so we're kind of going through this area of weather that has a lot of precipitation falling in that 6-hour window, and it's in inches over here, so we're talking about somewhere near maybe 1 to 1.5 to maybe even 1 3/4 inches in some places. I know I'm going to have a difficulty working my way through that. So again, maybe if I'm going from Charlotte, North Carolina to New Orleans here, that may be a lot less of a problem. So it gives me, again, the ability to understand what's going on. So this is a frontal-based kind of precipitation. It's got a upper level feature with it that's robust enough to cause problems. So there's lots of things going on here that will tell me very quickly that this, especially in the summertime, is going to be a problematic thing for flying through that area. So it gives you a good first look at being able to change your departure time accordingly. I also like to look at the Storm Prediction Centers. They have a day 3, day 2, and a day 1. So day 1 is today, day 2 is tomorrow, and day 3 is the following day. And this gives you a very broad brush overview of where the possibility of thunderstorms would be. And I kind of use this more for the white area than I do the green or the other colors here. Primarily because this is a 24-hour period. Once it's issued, it's valid over a 24-hour period. So it really doesn't tell you there's a marginal risk of severe weather up here in the Northeast. It doesn't tell you whether it's going to be in the morning or the afternoon or the evening. We can figure that out by using some other products to give us a better detail. But nevertheless, if I'm headed from Des Moines, Iowa up to, let's say, Billings, Montana, I know that I'm going to probably be outside of areas of convection. But we're going to see an example where that is may come back to bite you here. So ultimately, this is really more of a thunderstorm kind of outlook. But you can still have, even in these white areas, very, very sporadic areas of showers and possibly even a thunderstorm or two. But we're just talking about the certainty of where the thunderstorms would be. So there's a 1, 2, and 3 day forecast that you can look at too. Again, looking at the big picture. You can also get down even a 6-hour difference here. This is again 18Z to 0Z, so this is over a 6-hour period where you're looking again at the possibility or probabilities of thunderstorms. So the kind of the lighter hatched areas anywhere from a 25% up to 40. The thicker hatched areas are 40 to 75, and above 75 would be like the solid areas here. So, and you can give you a better idea where there may be soft areas that you can maybe work your way through in that particular time. So if you're planning again to go from, let's say, Baton Rouge all the way up to Chicago, this may be a doable flight, again depending on the timing of how that convection evolves, because there definitely is a softer spot here, if you will. But if you're flying from Raleigh-Durham up to Indianapolis, you're probably going to find yourself in a bad situation because you've got a lot of chance of thunderstorms and convection in this area. One of the products I use a lot myself, and I rely on this a lot, and this is from the Storm Prediction Center provides this information, but this is essentially another kind of approach to this. This is a forecast over a 4-hour period now. Again, the same kind of concept here where we're dealing with probabilities. So the higher the probabilities, the darker the red features are going to be. So it gives you, again, a better understanding, sort of at with a 4-hour window. You can actually get this down to a pretty nice, and using this on a regular basis, you can really pick out the best timing to fly. And this will change again depending on what kind of weather systems are moving through, whether you're talking about afternoon kind of stuff out west that you'll see. So it really helps pinpoint those problem areas. The same thing is true of this localized aviation MOS program called the LAMP from the GFS model. And again, it gives you a ability to kind of see things on a kind of low, medium, and high risk areas The nice thing about this is that it's updated every single hour. It only goes out to 24 hours in the future, but ultimately it gets updated every single hour. So you'll be able to see this on the day of your flight or even the night before your flight and be able to get an understanding of where the riskiest areas are. So the yellow areas are your high risk areas. So in this particular case, it gives you an understanding. Again, if I'm flying from Charlotte up to Baltimore for this particular time frame, I might not have to be worried a lot about thunderstorm activity, and it gives you again a good feeling of confidence. And you want to also kind of combine a lot of this together, because some of these products will tend to disagree with each other, but it may just be timing issues more than anything else. There's a lot of different forecast radar products out there. This is one I like. Again, it's from the Storm Prediction Center's website, and it shows you essentially what a NEXRAD image might look like in the future. So I know most pilots spend a lot of time looking at NEXRAD images, and they're pretty darn good at interpreting them. What happens if you had a future NEXRAD image? So this is a predictive scheme here where we're seeing the possibility of, it doesn't tell you whether it's a thunderstorm or not, but you can certainly see that it's very cellular structure. As a result of that, this is likely a convective process going in here. And the nice thing about this is that usually the time frames are an hour by hour over a period of, in this case, 36 hours. So again, 0 to 18 hours out. This may even take you out to 24 to 30 hours, but you can get an assessment, pretty good assessment for what the reflectivity might be in those areas. So it gives you a really good understanding of storm structure, whether or not you're going to have a line of storms, an area of storms, whether it's going to be very scattered or isolated or a solid kind of line. So this is one of my go-to charts for kind of making that kind of big picture decisions. And one of the other products that I use, and it's probably not widely known, but this is available on the National Center for Environmental Predictions website. But it also has what's called a probability, which from the high resolution Ensemble forecast, a probability where their echotops will be above 30,000 feet. So we know that the echotop is kind of the top of the precipitation core in convection. And when that top starts to get into the 30,000 higher range, we know we have deep convection in place. And so we're not looking at any kind of intensity here per se. We're just looking at what is the probability that the tops of that echotop will be above 30,000 feet. So this really highlights the areas that are going to be the most problematic in any area that you're planning to fly through. So an area that may be, let's say, really light in terms of low probability, you still may have some showery precip in that area, but it's not likely to grow up into the flight levels in that particular case. So you would have to be very concerned if you're going to fly under anything that's in that area. Again, if this is a forecast, and it goes out again 18 hours, even out at, as far as 36 hours in the future. But I generally look at this the night before I'm flying. And of course, you want to look at the terminal forecasts, and you'll definitely want to see things like whether or not you're going to be dealing with thunderstorms or showery precip in the terminal forecasts. And that's the important kind of thing to kind of pick up is these rain showers that we'll see in a bit. And also the Storm Prediction Center has what's called an enhanced resolution thunderstorm outlook. I know I'm inundating you with all these probability charts, but again, this gives you the highest probability, in this case 70%. So if I'm headed from Austin, Texas to, let's say, Santa Fe, New Mexico, this is telling me that this is going to be a problem. And this is usually over a 4-hour period. So if I'm going to be flying in that 4-hour period, this is likely, even this may be, there may be zero cumuliform clouds out there when this particular product is issued. As this time approaches, then you start to see some weather developing. So again, I'm trying to get an understanding of where the most significant weather may be, versus if I'm flying from Nashville down to, let's say, Orlando, that may not be too difficult of a flight for that 4-hour period. And of course, this is another simulate reflectivity or radar forecast radar product from the rapid refresh model. And just another kind of element to this. The nice thing about this product is update every single hour. You're going to get a new forecast. So again, I like to look at this usually the night before, late at night, or I look at it first thing in the morning. And of course, you want to also look at see where there's convective sigmets. Convective sigmets show you where active areas of convection that are dangerous for aviation are located, as well as these other areas which are kind of a gold or or tan or orange color outside of it, those are the convective outlooks that tell you that the area that you're seeing in those outlook areas between the period of 2 to 6 hours from the time that they were issued, they're likely to have convection developed that meets convective sigma criteria. And of course, lastly, you're going to be looking at NEXRAD. So you're going to be looking at the loops, NEXRAD, over the course of the last hour or 2 or 3 to kind of see how things have all developed. And then obviously in the cockpit, you'll be taking your Sirius XM product and you'll be watching what happens and how that all unfolds. But hopefully you've made a good decision that you won't be flying through anything significant here. One of the critical elements here is that you don't want to ever stop your analysis. So when you close the door in the cockpit and depart, don't stop your analysis. Your weather analysis should continue. And if it doesn't, you're going to find yourself in a world of hurt. And I'm going to show you an example of this. So this particular bonanza ended up in extreme convective turbulence at 7,000 feet. And for some reason, it ended up shattering the pilot's side window here. I don't really know what actually shattered that window, whether it was due to flexing of the airframe, but ultimately that pilot ended up in convective turbulence, ended up being basically turned upside down, spiraling down. The pilot recovered about 1,200 feet above the ground and had to divert to a small airport and overran the runway a bit. That's obviously, I mean, if I was in that situation, I probably wouldn't be looking to grease that landing. But ultimately, you see here that airplane is definitely reusable. But the pilot ended up into a bad situation. So they flew into what's called low top deep moist convection. It had no lightning associated with it. And basically, this is one of those little rain showers that they ran into. So again, don't ever stop doing weather analysis. Keep that weather analysis going. Look at your Sirius XM weather. Make sure you understand what's going on. Relate that to your pre-flight briefing and make sure you keep that analysis going. So here's what happened. They were headed from northern Illinois, going down into eventually into Tennessee, and they had to divert here to I-96. And what you see here on the NEXRAD, now this pilot actually had the FSB product in the cockpit, and they passed by Louisville here, and this is kind of the flight path. What you notice is these are just little rain showers here, nothing significant, no lightning associated with it. Certainly just a lot of rain showers all over the place, but it's very cellular. It's a cell here and a cell there. That's a convective process in place. In fact, Louisville had a forecast out here for VCSH, which means showers in the vicinity. That's the area that's 5 to 10 miles, a donut-shaped area around the airport. So even the forecaster was throwing that word showers out at you. No thunderstorms, but showery precip. Notice there's no CBs in the cloud group here. And so this is really what was happening. This pilot was headed in that direction from kind of a northwest to southeast orientation along the route. And most likely what that pilot kind of saw as it was approaching this area was just a very light area precipitation on the FSB product. Unfortunately, we know that this cell here developed. Hopefully this will come out well, but this cell developed as it's going here just sort of south and kind of east of Knoblich here. And it developed into a pretty significant little rain shower. And when that pilot ended up in that cloud and in that updraft for that developing storm, that's what ended up turning him upside down. So this was just a simple little rain shower. Probably should have diverted around it. And certainly the latency in the product is certainly a part of this problem, but in the end, it's looking outside the cockpit and understanding what you're about to fly into, and understanding that cellular appearance and the possibility of the showery precip. And so if you look at the Storm Prediction Center convective outlook for that day, it's in the white area. So again, you can't necessarily say that that's completely free and clear of any convection, and we'll see why that is. Again, the big picture tells you this. There's the frontal system, and certainly the frontal system is already passed, and normally the frontal system, if it's already passed, you got subsidence and sinking air behind this on this high pressure, and usually it kind of dries the air out, not much goes on, but you really got to look at that upper level picture here. So kind of behind that frontal system, that's already headed just about off the east coast, you still have the upper level trough that comes through here. An upper level trough is just some cold pool of air aloft, and that's enabling. You have cold air aloft, and you have, if you look here, you got some really kind of warm temperatures, 84 and 75 near the surface, some heating of the day kicking in. Cold air aloft, and that produces a lot of instability, and these instability showers are what triggered those that you saw in the next rad. In the end, a forecast for showers is a forecast for convection. And so anytime you see rain showers in the vicinity or rain showers in the terminal area, there's going to be no CBs on it. That's an important information to tell you this could be a convective environment. And so again, sometimes the forecasters use these rain showers as a placeholder for a low confidence thunderstorm event. It's important that you want to check and read through the area forecast discussions. They're issued by the same forecasters that issue the TAFs. So in this particular case, not for this particular accident that occurred or incident, but this was from my area here in Charlotte, from the Greenville-Spartanburg Weather Forecast Office. And you can see here they say scattered showers and perhaps a thunderstorm, but you see scattered showers are expected across the North Carolina Piedmont from the afternoon until early evening, and will carry showers in the vicinity for an hour to cover that threat. So again, they're telling you, hey, there's a really uncertainty in this forecast, but we're going to throw in showers in the vicinity so we can tell pilots out there, by the way, this is a convective process going on. You might want to think twice about this, or at least be careful about this situation. So the TAFs themselves, they don't like to put thunderstorms in the forecast just to cover it, so they'll put showers in the vicinity or rain showers to cover the threat of a possible, let's say, very difficult to forecast convective environment. All right, so that's a lot of information thrown at you there. Again, my name is Scott Dennstaedt, easywxbrief.com. I offer a 14-day trial, and there's my email address.